Hey, welcome back everyone for this last session where I'll talk about this last paper called Speakers Fill Lexical Semantic Gaps with Context. And this one was joint work with Rowan, Damian, and Ryan. So we all know that words can mean more than one thing, right? Like, for example, consider the word in English, buffalo. So buffalo can be an animal, and then you can pet a large buffalo. Buffalo can be a US city, so you can visit Buffalo. And buffalo can mean intimidate as well, so you can buffalo someone. And you can even say something like buffalo, 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 buffalo. The question we're asking in this paper is if speakers compensate for this lexical ambiguity by making the words more predictable and context. So as to make it easier for the listeners to understand this. So putting it differently, we're asking if there's a negative correlation between contextual uncertainty and lexical ambiguity. And just as a side note, to be clear, although in the way we pose the question here, it might sound like we're looking for causality. We don't test for causality in any way. We're only looking at correlations here. So to get these correlations, we'll need operationalizations for both these measures. And we'll start with lexical ambiguity, which we operationalize with this entropy here. And what this entropy is measuring is how much uncertainty you have about the meaning once you know the word. So given that you know a word out of context, like buffalo, how much uncertainty do you have about the specific meaning that this word should represent? And we note that this is equivalent up to an additive constant to this mutual information. And this is kind of obvious, but it just says that the more lexical ambiguity you have in a word, the less informative that word is about its meaning, and vice versa. So we'll operationalize lexical, we'll use our operationalization of lexical ambiguity using approximating it in two ways. One uses Wordnet and the other one uses BERT. And this is interesting because they have such different properties, and they will allow us to explore a different set of languages and perspectives on how the meanings are encoded. So Wordnet has discrete senses, while BERT uses a continuous meaning space. Wordnet is hand annotated, BERT is unsupervised. Wordnet is only available for high resource languages, where BERT is easily obtainable for new languages. And for Wordnet, what we do is we assume a uniform distribution over the senses a word has in Wordnet. And then it's easy to get an estimate for these lexical ambiguity. For BERT, we assume the embeddings are the contextual embeddings are the word meanings. And then we use a Gaussian approximation, a max entropy upper bound, to get an estimate of this lexical ambiguity. So while Wordnet will be more precise in some sense because it's hand annotated, BERT will allow us to explore a much larger number of languages. And while Wordnet will not differentiate things like homophony, where different meanings are more spread apart, different senses, BERT will take this into consideration when measuring lexical ambiguity. So how well do both of these measures correlate? We're trying to approximate lexical ambiguity, so let's evaluate how well we can do it. And they correlate really well, relatively well at least. For English, for example, we get a correlation of 0.4, which is quite good for such a noisy way of doing stuff. And here are the plots. And this is quite interesting, and especially because by analyzing these results, we see that the correlation seems stronger when either BERT or Wordnet are better. So for example, English has the highest correlation, and English has the the largest coverage in both Wordnet and the largest Wikipedia where BERT is trained. So it seems that we can make these measures better by just increasing the quality of contextualized language models or increasing the size of Wordnet. We also operationalize here contextual certainty as a half-point-wise entropy. And what this one is measuring is how uncertain am I about the word in all the contexts where this word appears. And we can approximate this value with a closed language model. And as a side note here, we note that we use bidirectional context. So both the left and the right context of the word are used when predicting it to get this half-point-wise entropy measure. And this is different from most prior work that has looked into this kind of question. So let's go on to our empirical findings. Is there a trade-off? So when we use Wordnet, we do find this trade-off in 5 of the 6 analyzed languages. And here are some plots with contextual certainty and the polysymmetric using Wordnet. And you can see there's indeed a downward trend where words with more senses in Wordnet will have smaller contextual certainty on average. When we use BERT, we find in all 18 analyzed languages this trade-off. And here are the plots again of lexical ambiguity versus contextual uncertainty. And by looking at these plots, we find this interesting pattern that the most ambiguous words seem to have especially small contextual uncertainty. So there seems to be something going on here. And we note that the correlations when we use BERT are much stronger than when we use Wordnet. And that might be happening for a few reasons. One of them is that BERT will take into account homophony versus just small variations of word sense when calculating lexical ambiguity. The other is that BERT might be biased towards frequent or some kind of words, and that might be confounded the results. So, but the fact that both Wordnet and BERT show this correlation makes us more trusting of these results. So now that we see that this trade-off exists, let's go deeper into why it should exist. So to talk about why, we'll define this principle of clarity here, which states that a listener should be able to reconstruct a speaker's meaning. So if I'm talking to someone and I speak something, they should be able to reconstruct the meaning the words I said convey. And this can be operationalized with this entropy here, which is basically the uncertainty of the meanings given that you know the word and the context. So the uncertainty of the meaning given that you know that you heard the full sentence. We also need to talk about robustness here, which is the principle that a speaker's utterances should be resilient to noise. And we operationalize it with this tripartite mutual information, which is the redundant information encoded both in the meaning, the context, and the word. So the information about meaning that is passed both by the context and the word redundantly, and that should make the communication more robust. So why should there be a trade-off then? If we assume a language is clear, this entropy here should be 0. There should be no uncertainty about the meaning once I know the full sentence. If we assume the language is robust, this tripartite mutual information should be above some constant k. So there is some redundancy or robustness in the language. And we can split out this tripartite mutual information in these 3 terms, which are composed of the lexical ambiguity and the contextual uncertainty of the word plus a constant. And if we reorder these terms, we get to this equation here, which shows that there should be a trade-off. Since you have these two additive terms that should be smaller or equal to a constant, if one grows, the other one should be reduced in order that this sum doesn't go above this threshold. And that's it for this last paper. And now we'll go into some takeaways that we can take from these papers. So what did we see here? We saw that phonetic complexity trades off cross-linguistically with the average word length. We saw that there is a tendency for word initial segments to be more informative than word final ones. We saw that we can measure systematicity of the sign, and that we can find significant systematicity both within and across languages. And we also saw that we can operationalize lexical ambiguity, measure it in an unsupervised way, and that there is a trade-off between lexical uncertainty and contextual uncertainty. So what we can take from here is that if the phonetic complexity correlates with word length, maybe it's because there is a pressure towards a roughly equal size phonetic space. So if you have more options of segments at each point in time, you might need only shorter words to represent the space of meanings that you want. While if you're more constrained in the set of choices you have, you might need longer words to be able to represent the full phonetic, to support the full meaning space, and to have a roughly equal phonetic space at your disposal for communication. The fact that there is a tendency to front load information might imply that there is a pressure towards faster lexical access. If the information comes early on, then maybe speakers can recognize the words earlier, and that will be make language more efficient in some sense. The fact that speakers compensate lexical ambiguity by reducing contextual uncertainty might imply a pressure towards fewer communication errors. And the fact that semantically similar words have more similar forms might be a pressure towards learnability. And all of this and these pressures have some, or most of those pressures at least have some support in the psycholinguistics literature. So while we don't go into the cognitive reasons for these results directly in this analysis, they might give us glimpses using natural corpora without any lab experiments into these cognitive processes and the pressures that they imply. So we can analyze them in these naturalist settings. And yeah, I'm not the only one working in this kind of information theoretic linguistics. There is quite a few people that do this as well. If you're interested, just search, for example, the work from Roger Levy or Futrell or Piantadosi. They do very cool stuff on this. I'm just starting, but yeah, going forward in my PhD, I'm probably gonna try to go a bit deeper into the cognitive science behind this and try to connect this with cognitive experiments, not just look at the natural data, but try to run lab experiments to confirm what's going on behind this. But yeah, if you are interested, feel free to email me or message me at any time. And yeah, thanks for watching. And thanks to all my co-authors here as well. And that's it. Let me try to stop the recording. Okay, see you.